Now, since we have the multiplication property of radicals, why not talk about the division property of radicals? So it's very similar to multiplication. It's if you have the nth root of a divided by b, it means that that's the same thing as the nth root of a divided by the nth root of b, where n is a natural number, remember, greater than 1. And a and b are real numbers, so they can be a decimal, they can be a fraction, they can be an irrational number, and b can't equal 0 because we can't ever have 0 divided. You can't have division by 0 or zeros in the denominators. So n is called the index. To simplify radicals, look at the index. So if n equals 2, look for perfect squares. If n equals 3, look for perfect cubes, etc. Now we did some practice work on this yesterday, so this is kind of just upping the ante a little bit. It's like doing exactly what you did yesterday, but we're just going to put some fractions into it. So we want to write this as a mixed radical. So since we have an index here of 3, we're looking for perfect cubes. So if I just want to write this down, so 1 to the 3 is 1, 2 to the 3 is 8, 3 to the 3 is 27, 4 to the 3 is 64, and then 5 to the 3 is 125, and that's all we're going to really need for this. All right, so first things first, I'm going to say 3 root, and because we have a negative number here, we often become afraid, but don't worry about it because we have that cubed root that will take care of it. So let's make that negative just attached to the numerator. You can pick the numerator or denominator, but I like the numerator. So 16, or negative 16, is negative 8 times 2. And then 135 is going to be 27, which is a perfect cube, times 5. So what I can say here is the cubed root of negative 8 times the cubed root of 2, not 3 times 2, but this is the index, okay, over the cubed root of 27 times the cubed root of 5. So all I've done is, instead of everything being under the cubed root radical, or the cubed root sign, I've just made them all separate. Because I know I can simplify this. The cubed root of negative 8 is negative 2. The cubed root of 27 is 3. And then I can stick these guys under the same radical sign again. The cubed root of 2 over 5. And that, my friends, is it. And now what we're going to do is we are going to go the other way. Now, first thing we should realize here is that the index is 4. So we need to get this as an entire radical. That means this 3 that's in front, we need to make it underneath the fourth root. So this negative sign, we need to keep it out from underneath the radical sign, because since it's an even, okay, since it's an even index, we can't have a negative sign underneath the radical. Because if I were to say the square root of negative 16, I need two numbers that are exactly the same, okay, exactly the same in sign and value to multiply to 16. That doesn't work. It doesn't equal anything. Well, actually it does equal something. It's something like an imaginary number. So the square root of negative 1 is I. Okay, but we're not going to be dealing with any, and you might think that I'm making a joke about that, but that is certainly true. The square root of negative 1 is I, and it's the imaginary number system. I know us mathematicians are crazy, but if we're working in the land of real numbers, which we are in this course, we have to realize that you can't have a negative sign underneath a radical. So in order to get the 3 into the same form as this fourth root, I'm going to say, okay, what what to the fourth root is 3? Well, if I were to say 3 to the power of 4, that's 81. So I'm just going to highlight this, okay? 3 and the fourth root of 81 is the exact same value. And just for kicks, I'm going to put this over 1 because we have a fourth root here of 2 over 27. So I'm going to keep this negative sign out in front to have the fourth root of 81 times 2, which is 162 over 27. And that, my friends, is our answer. That's the entire radical. It means that the entire thing is underneath the radical sign. Save that negative, but we talked about that.